Bismillah, alhamdulillah, sallam. Our lesson, the similarity in the two triangles. We know the similarity of the two polygons. If we have the two polygons with the same number of sides, we said too the two polygons are similar if number one, the corresponding angles are equal in measure and the corresponding sides are proportional. Corresponding angles are equal in measure and the corresponding sides are proportional. We know the ratio between two corresponding sides, it's called the factor or ratio. If the ratio between two corresponding sides greater than 1, it's mean the first polygon is the enlargement of the second polygon. If the ratio less than 1, it's mean the first ratio minimization or minimization to the second ratio, to the second polygon. If the ratio between two similar polygons equal 1, then it's mean the two polygons are congruent. Okay, what about the square and rectangle? Here the square, the measure of each angle equal 90 degree. Rectangle, the measure of each angles equal 90 degree. Then the two corresponding angles are equal in measure, but the corresponding sides is not proportional. Then we can said then the square doesn't similar of rectangle. What about square and rhombus? Square and rhombus, the rhombus and the square all sides are equal, then the corresponding sides are proportional, but the angles is not equal. Then the square doesn't similar of the rhombus. Here we are talking about the similarity in the two triangles. In any polygons, to said to be the two triangles are similar, we must the two conditions satisfy the two conditions. Corresponding angles are equal in measure and the corresponding sides are proportional. But in the triangle, the two triangles are similar if one of the following conditions verified. Number one, the measure of their corresponding angles are equal and the lengths of corresponding sides are proportional. Here in the triangle special case, we said to be the two triangles are congruent if one of the conditions are verified. The measure of their corresponding angles are equal or the lengths of corresponding sides are proportional. If two right angles are similar, if the measure of an acute angle in one of them is equal to the measure of an acute angle in the other. Right angle triangle, it's mean one of angle equal 90 degree. If find the another angle, acute angle in the first triangle equal acute angle in second triangle, so the third angle equal third angles, then the two triangles are similar. The two equilateral triangles are similar. Equilateral triangle, it's a regular. We know all regular polygon on the same number of sides are similar. All equilateral triangle are similar. All squares are similar. All regular hexagon are similar. Then all equilateral triangles are similar. The two isosceles triangles are similar if the measure of an angle in one of them equal the measure of the corresponding angles in the other. We know isosceles triangle, two sides are equal and the two angles are equal. If we find the angle in the first triangle equal the corresponding angle in second triangle, then the two isosceles triangles are similar. Example: AC parallel to DE. Measure of angle, the length of AC equal 5, BE equals 8, AB equals 3, BD equals 6 centimeter. Prove that number 1, the triangle ABC are similar to triangle DBE. Number 2, find the length of BC and the length of ED. First, AC parallel to ED and AD is a transversal to them, then the measure of angle A equal the measure of angle D, alternate angles. Letter Z, measure of angle A equal measure of angle D. Since AC parallel to DE and CE is a transversal to them, then measure of angle C equal measure of angle E, alternate. Here we have two triangles, ACB and DEB. We have two corresponding angles in the first triangle are equal to two corresponding angles in the second triangle. Then the third angle equals third angle. Here, measure of angle ABC equal EBD, vertically opposite angles. Then we have three angles on the first triangles are equal the corresponding angles on the second triangle. We know we have two conditions to make the two polygons are similar, but the triangle, we must find one of these conditions. The corresponding angles are equal in measure or corresponding sides are proportional. Here, three angles on the first triangle are equal corresponding to the second in the second triangle. Then we can write that two triangles are similar. The triangle ABC are similar, DBE. Two triangles are similar. Then their corresponding sides are proportional. Then AB over DB equals BC over BE equals AC over DE. Here AB 3, DB 6. BC, we don't find the length of BC. BE equals 8, CA 5, and ED equal ED. Then BC equal 8 times 3 divided by 6 equals 4 centimeter. ED equal 5 times 6 divided by 3 equals 10 centimeter. Number 3, the ratio of enlargement equals 6 divided by 3 equals 2. Here he want the ratio of enlargement. Enlargement we start to the bigger number. Bigger number here 6. 6 divided by 3. If you want to find the ratio of minimization, we start with the smaller length. Enlargement, we start off the greater length. Minimization, we start off the smaller length. Another example. Here, in the opposite figure, measure of angle AED equal measure of angle B. And the length of AE 5, BD 6, and AD 3 centimeter proves that the two triangles ADE and ACB are similar. Then find the length of EC. Here, on the given, the measure of AED equal measure of angle B, first angle. And the angle A is a common angle. Angle A is a common angle. Then measure of angle C equal measure of angle ADE. In any two triangles, if we find the measure of two angles on the first equal the sum of two angles on the second, then the third angle equal the third angle. Here we find three angles on the first triangles are equal corresponding angle of the second triangle. Then we can write the triangle ABC similar triangle AED. Now write the corresponding sides. Corresponding sides are proportional. Then AB over AE equals, we start from the smaller triangle. AD over AC equals AE over AB equal ED over BC. AD 3, AC, we doesn't know the length of AC. AE 4.5 and AB equal 9 centimeter. Want to find the length of AC? Then AC equals 3 times 9 over 4.5 equals 6 centimeter. Here the length of AC equals 6 centimeters, but the length of AE equals 4.5. The length of AC equals 6 and the length of A equal 4.5, then the length of EC equals 6 minus 4.5 equals 1.5. Here, what about BC and ED? Here we don't know the length of any sides of DE or BC, so we can't find the length of the two sides. We can find the ratio between two sides. The ratio between sides equals the ratio between any two corresponding sides equal 1 over 2. But we can't find the length of DE and the length of BC together. Example number 3. In the opposite figure, the two triangles already similar, and the ratio between AD to DB equal 1 over 3. AD to DB. AD1, DB 3 parts. Then the ratio between AD to AB equals 1 to 4. Then the ratio between AD to AB equals 1 to 4. You want to find the ratio between AE to AC. AE to AC equal AD to AB. AD to AB equals 1 to 4. Then the ratio between AE to AC equals 1 to 4. If the length of DE equals 4, find the length of BC. Here, DE over BC equals 1 to 4. DE equals 4. 4 over BC equals 1 to 4. Then the length of BC equals 4 times 4 divided by 1 equal 16 centimeter. We study today the similar and the two triangles. We know the similarity. The two polygons are similar if corresponding sides are proportional and the corresponding angles are equal in measure. In the triangle, the two triangles are similar if we satisfy the one of the two conditions: corresponding angles are equal in measure or corresponding sides are proportional. Thank you and goodbye.